Hi everyone, welcome to CS50 sections week 6. Today we're going to talk about Python, and my name is Yulia. I am a preceptor here on Harvard's campus, and I help run our on-campus class as well as everything that we do online. And today we're really diving headfirst into Python, so we're going to talk about syntax, in particular lists and strings. We're going to really delve into for loops and how they're structured, comparing them to C, which we worked so much with over the past few weeks. We're going to talk about dictionaries as well, which are really very similar to the real life dictionaries, where we have some keys or the words that you're looking for and values or the definitions that you might look up in an actual dictionary. And we'll close off with file IO or file input output, particularly focusing on how to handle CSV files, how to read data from them and then manipulate them afterwards. But to get us started, let's talk about some differences in syntax between C and Python. So for example, on the very top, we can see a very common line of code that we used all these past few weeks, the way how we get input from the user, right? For example, their name or word or something else we would like to use in our program. On the bottom, though, is the Python version of that code, and you can even tell without maybe even knowing anything about Python or C that the Python version is so much more simpler. So let's break it down a little bit part by part, talking about the differences between the two. So the first thing that stands out to me is char, right? Which we used to call string the first few weeks of the class before we took our training wheels. And we don't see that in Python anymore. And while data types, of course, still exist, we don't have to explicitly tell our computer what data type, what variable is. Python sort of like handles it by itself. This is like where its magic sort of begins. But as you remember, in C, we had to explicitly state if it was an int or a float or a string, etc. Next part that stands out to me is the semicolon. So you notice that on our top line of code, we have a semicolon in the end, while the Python line of code doesn't have that anymore. And that also goes for curly braces, like semicolons in other cases, Python or parentheses, even around like the if conditionals and for loop declarations. Python really doesn't have that annoying punctuation anymore, so you don't have to keep track of that. But on the flip side, the indentation is becoming a big thing in Python, where we really have to be careful with our indentation, as that's how sort of like Python will read our code. So if you are not used to doing that in C, now is certainly the time to get your code a little more organized. Well, let's talk about if statements and also printf or print now in Python. So again, let's break it down one by one. So let's start with the if statements, right? The first thing that we have on the top line of our code is strcmp or string compare, which we use to compare, for example, a variable or another string, or we compare two strings, right? In this case, we have some variable called phrase that is presumably storing some kind of word, and then we want to compare if that word is actually hello. And then if it is equal to 0, then we know that all is good, they are equal, and we can move on. But now if we looked on the bottom line of our code, right, we don't have strcomp anymore, we don't have to check if it's equal to 0, we can literally just ask, is phrase equal to hello, right? The only thing that sort of like stays is the double equal sign. But other than that, like, right, we're like peeling away all these like functions or additional syntax that we used in C. And moving on to like inside of our if statement, right? Like if the if statement is actually true, we will print something out. Well, what would we print? We would print hi, comma, name, right? Something that the user presumably like inputted before, and now we can print it out in the terminal. Well, the first thing that stands out to me is that we used to have printf, now we just have print. So again, Python is sort of very similar to your regular English language. So it is easier now to write pseudocode in plain English and then translate it to Python, because a lot of words literally translate as you just write them in regular sentences. Next thing is the placeholders in C, right? We always had to make sure if we wanted to make our printf statement more dynamic, right? Pass in some values from the variables, we had to make sure we have those placeholders. Well, in Python, we don't have the placeholders anymore. In turn, slightly different formatting, right? But still no need to keep track of the placeholders or the order in which you need to put variable after the comma. Now we can sort of use either the F formatting or a plus sign that we will see in just a moment. Well, let's talk about lists now, right? So lists are very similar to the concept of the arrays that we've talked a lot about in C, and that was our like primary data structure that we relied a lot during the first few weeks of learning C. In Python now, we have lists instead. Very similar concepts, it's just a collection of some items. We still use the same syntax of putting the items inside of the square brackets, but now something is different, right? So I'm gonna give you a few seconds to maybe think to yourself, what might be different here, right? It's the data types. So in our list, it's literally called my list. Now we have a combination of different items. We have a string called testing, an integer 1, a float 2.3, right? So this is where the power of Python kicks in. Now we can combine all the different data types in one list, right? And we can access them as easily. Well, if we visualized our list as such, right, again, it's stored continuously, so it is one after another. But now, what if I wanted to add another element to our list, right? What if I wanted to add something else? Well, recall that in C, if we wanted to make our arrays bigger, we had to go through a whole process of various tedious things, from allocating the memory in the very beginning, reallocating the memory to resize the arrays, make them bigger, accounting for how much bigger we want them, error checking along the way to make sure we're actually getting back the memory that we want. But in Python now, all it takes to add another element to the list is one line of code. So now, if I simply write my list.append, and inside of the parentheses, I put the value or the element I would like to add to the list, that is all it takes. And it gets added to the end of our list. And here we are now with 4 elements. And again, it could really be anything. It could be a string, a float, an integer. You could make lists of any data types that you want. And that's a really powerful thing about Python. But let's zone in on one detail. So .append, that's new, right? We only dealt with functions before, so it would be function parentheses and we put something inside the parentheses. But now it is sort of a little different, right? We have this dot operator, and it's sort of like we have just a variable that we want to use and then some operation that we want to do on that variable, and the dot is what connects it. Well, the reason for that is that Python is object-oriented programming, so we now have methods, right? And we have objects that we can apply these methods to. So for example, my list is a list, and the list has certain methods. For example, append, insert, pop, reverse sort, etc. You can find more online. And these are different operations that we can do with the given list. The big difference, right? It's like, contrary to functions, we don't put list as a variable inside the parentheses, we put this method after the variable, connecting it with the dot. So for example, append will just add an element to the end of the list, pop will remove some element, reverse will literally just reverse the list, and sort will sort the list according to the values. And there's so many more different methods, and actually even the methods that are on the screen right now also take different arguments, and they're very customizable, right? So now we're like really leveling up with Python and increasing the number of different operations and tools we have to manipulate our data and the variables that we have. Well, let's consider another data type, a string. So recall that during week, I think it was week 1 or week 2, we had a readability problem. And this was one of the phrases that we gave you guys to test your readability program and if it's outputting the correct grade level. So you're off to great places. What can we do with these strings? Well, recall that strings are just list of characters, right? So while they're not necessarily lists, and I'm coming to the point where they have different methods than lists, it is still an object, right? So we can do different operations with it. One of its operations is lower. So what it will do, it will take the string that you have and convert all of the values to lowercase. So notice that Y, G, and P were all uppercase letters, but after applying lower method, we made all of the letters lowercase. Well, what are some other tools that we have in our toolkit now? One of the other ones is capitalize. And what that one will do is grab the first letter of your string and then capitalize just that one letter, leaving all the other ones lowercase. So note that before we had GP uppercase, but now after applying the capitalize method, only Y is capitalized. And you know, if you want to capitalize, if you have a sentence, which is an interesting part, so if I had you're off to great places, period, and then I had something else, only the first Y would be capitalized. So again, you can play around and see how these methods respond based on the different inputs, right? So what are some other ones that we have? So we talked about lower and capitalize. There is also is space that checks if the whole string is spaces. And then split will split based on the delimiter that you give it. So for example, if I wanted to split by spaces, I would get back you are off to great places, right? Separated by spaces and then put into a separate list where I now have 5 elements because that is the number of words I had in my phrase. What are some other ones? Strip would remove some characters to sort of like isolate the word that you're looking for. Very commonly used with white spaces. So when you have like space, 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 the word you're looking for is space, space, space. You don't want to store all of those spaces. So just stripping it of spaces is very helpful. And upper, contrary to lower, just makes all of the characters uppercase. Okay, so lots of different methods that exist for both lists and for strings and different customizations that you can make with them. So definitely encourage you to go online, look at Python documentation, and figure out what other cool things you can do with it. But here, we're gonna move on to for loops, right? Another very powerful tool that we used in C really all throughout the past, 6 weeks, right? Even when we were just starting with Mario during week 1 or even with Speller in week 5, odds are you used for loops in one way or another. So for loops are not just exclusive to C, they also exist in Python. So again, let's talk about some differences that exist between the two. So on top is a very common, like formatting and setup that we've seen before. So this is how we would start a for loop in C if we just wanted to print out I from 0, sort of like values 0, 1, 2, right? So all it would do was initialize I to 0 and then increment it by 1 until I hits 3, in which case we want to stop. Well, if we were like literally translate that to Python, it might look in the way that we have on the screen right now. So for I in 0, 1, 2, but I'm sort of like guessing, right? Like I know that in C code, I have I less than 3, so I can guess that it should be 0, 1, 2 on the bottom, but how can I make it more dynamic, right? Like what if my 3 changes? Like do I need to write out 0, 1, 2, 3, 4 if I want to make my for loop like bigger with bigger values? There is a very handy function called range, and we're going to walk exactly through each component of it. But what it does is exactly what we had on the screen before, right? Just extracting the values or making the list of values that I will go through later. So let's talk about range, for loops using range. So again, syntax is very similar. So if before we had for int I equals 0, now we just have for I, right? We don't have to explicitly tell Python that it's an int, and where to start is what range is going to tell us. So the way that range works, it takes in 3 arguments. So the first one is start, and it is inclusive, right? So if the first argument is 0, then the first value of I will be 0. The next argument is end, and it's actually exclusive, so very similar of how we did for loops in C. And the last argument is step. So take one step between each iteration, or literally just I++. That's the exact way that we did before, just again, different syntax. So literally range parentheses 0, 3, 1 will give us that list of 0, 1, 2 that I can then loop through. But I argue we can do better than that, right? Actually, in range, 0 start and 1 step is the default. So instead of, taking some space and writing it out, I can literally just say for I in range 3, and it would achieve exact same results. So again, lots of cool things that you can do in Python. The way you can simplify the code, right? As Professor Malin showed in the lecture, we can write speller that took us probably hours in C in just maybe a couple of minutes, using way less number of lines, but still keeping the same functionalities. Well, can we iterate just through lists using for loops? Sort of, right? Because strings are lists of characters, but we can also iterate through strings in the same way that we did in C. And so if I literally had to translate what we did in C to Python, it might look something like this. So for I in range, right, we already learned that range will start at 0, and then it will take step 1. So we really just need to specify the endpoint. And in this case, the endpoint is the length of our phrase, right? So similar to strlen that we had in C, now we just have len, and it will tell us the length of the string, the number of characters that that string has. And then inside of that for loop, I'm just going to say print phrase square brackets I, right? Just like indexing into every single character that we have in our phrase using the index I. But I would argue that's not a very Pythonic way of doing things, and that we could do better. So these 2 lines of code can be simplified to just this. So for char in phrase, print char. And you can say, well, how does Python know what I mean, right? I'm not explicitly telling it what to print, what to grab. How does it know that char is actually each character that I mean? Well, this is sort of again, where we wave our hands and we say, this is the magic of Python. So it knows that if I say for char in phrase, it literally needs to look at every single element in this string. So more specifically, the char variable is going to represent sort of phrase 0, phrase 1, phrase 2, without explicitly calling those indices. So this is again where Python takes care of a lot of things for us, and we don't have to explicitly mention what to do. Well, that was, a lot of information. So now let's see it in practice and play around with some string predictions, right? So we're going to have some for loops, and we're going to figure out what each of them prints out. So let's move to CS50.dev, where I have pre-made some files that we're going to play around with. And let's start with round 1. So, oops, that's not what I wanted to do. Let's see, cd. Oh, okay, cd str prediction. And then I'm going to open round 1. Okay, nice. This is what I wanted. let me clear my terminal. I'm gonna close this, and this is what I pre-wrote before. So same phrase as before, right? We're off to great places, and now let's play around with the for loops, right? And different print statements. So let's walk line by line. So declaring the phrase, we've seen that before. On line 3, I am just printing out some static tags to really just like guide myself. And then the interesting part is happening on line 4, right? So before we saw range line phrase, but now it's slightly different. So now we're starting at 0. We're going until line phrase, but now we're taking step 2, right? Instead of step 1. And I'm going to give you a couple of seconds to think on it on your own before I run in the terminal. But what are we going to see in the terminal, right? Like what characters will be printed out? And hopefully you made your guess, but we will just see every other letter, right? So on top, we have Y-O-U, but here we just see Y-U, we skip the apostrophe, we see R, we skip E, and then we just jump 2 characters over each time, right? So not as helpful for the scenario with the strings because presumably we want to see every single character, but there are certain scenarios where you want to jump over just 2 times instead of 1. Okay, let me open round 2 and let's see what's inside of it. So here, slightly different setup, right? So now instead of our range function, we only have 2 arguments, and might be a little bit confusing, right? When in the beginning we said it was 3, and then we were like, okay, we can have 1, and that's like, I can wrap my head around that a little bit. We just need to specify the end, but now we don't even specify the step. Well, again, this is, I'm gonna say it a lot more times during this section, but this is the magic of Python, right? It just like takes all of these like tedious steps away and then does it on its own. So it takes some time trusting the computer to do the things you want it to do, but ultimately it achieves the same goals. So let's look at line 4 more closely. So again, what's going on here? We're starting at 1, index 1 now instead, not 0. And then we're going to the length of phrase minus 1. So I'm gonna give you a second to figure out what the printed out phrase might be while I am setting up to run it, but it will just be the whole phrase minus the first letter and the last letter, right? So notice how we don't have capital Y anymore, right? We skip that, and we don't have S. We skip that as well, sort of like cutting it off a little bit. Okay, let's move on to round 3 now. So here, I have something very similar, right? Like this is something that I just told you would happen on the slide. So if I say for char and phrase print char, it will print out just all of the characters. So let's see it in practice. Let me run this program, round3.py. And indeed, I literally just see my string. Again, not super helpful because we could have just said print phrase, but to make a point, let me put the end as spaces. And so now, let me clear my terminal. Let me run the same command again. They're all spaced out by 1 space, right? So hopefully after this, you do believe me that if we say for character in phrase, it will literally print out every single character or element that we have in a given string, here in this case, separated by white spaces. Okay, let me clear the terminal and open the next round instead. So round 4. Here, slightly something different, right? Like we have not really seen that before. So on line 4, I still have 4 character in phrase, but now I'm using square brackets, colon, right? That's slightly different. But what it really is just what is called slicing. So let me do the following. Instead of printing out the characters, instead of printing out the for loop right away, let me comment it out for just a second and let me print this sliced list. Phrase 7 colon. Let me run this program. Oops. Python round4.py. Okay, so let me clear the terminal and run that again. Okay, so what we see, right, is we don't have UR anymore. It is just off to great places. And I cheated a little bit. I counted 1, 2, 3, 4, 5, 6, 7. So I knew exactly where I would need to start from to just get off. But this is a really good example of how you can just subset into the strings, right? Print out or grab just the parts that you're interested in a very easy way, right? Just one line of code will achieve that for you. And we could also specify the start and the end. For example, if I wanted to just print the word off, I could start at 7 and then end 8, 9, 10, 11. Let's see. Exactly. So now I just have word off by starting at 7th index and ending at 11th. Okay, so let me delete this part and let us actually print out this for loop. So let me clear the terminal again. Let me run this program. Okay, so off to great place what we saw before. And again, just to prove the point one more time that Python really knows what you mean with just very simple English words, let me clear the terminal again, run the program again, now adding white spaces between each character, and then see what happens. Boom, we have each character printed out with a space between it. Okay. And lastly, I have one more example to show you. So let's go to round 5. And now is the split method that I was talking about earlier, right? So for word in phrase, split on white spaces. And as before, let me comment this out for just a second and let's print out just the split part to visually see what we're getting. So if phrase is your off to great places, it's a string. So we're adding a split method to it. And what will it do? Well, as I mentioned before, it will just return a list of elements where split has separated it by. So in this case, we want to separate by white spaces. So what I'm going to do is run this program again. And now what we see is a list of words, right? So it literally just looked at the string that I gave it, looked where the white space is, and then just like separated it, right? So UR is a separate one, off is a separate one, to is a separate one, great and places are all separate words. They're separated by white spaces. So that's why we see this list now. Well, let's go back to our for loop and see what is printed out. So again, if I literally say for word in phrase dot split parentheses white space, and I could have done something like modified and then remove this part, have more of stepping stones along the way, right? For word and modify print word, what I would see is just all of the words printed out separately, right? With the new line, because I didn't specify what my end is here. Now all separately after we split them by white spaces up top. Okay. And this is certainly a non-exhaustive list of cool things and tricks you can do with strings. So we only saw one method. We played around with for loops a little bit. There's certainly a lot more things you can do and functionalities of Python that are not really, like visible to you from the very beginning. So I definitely encourage you to go read a little bit about Python and its documentation, but really play around with all of these different examples to really explore all of capabilities of Python. Okay, let's go back to our slides, and now we're going to talk about dictionaries, which is again another data structure, a really powerful tool that will be helpful for us today and overall in your Python journey. So let's start with some syntax, right? This is how a dictionary in Python might look like. So if, for example, we wanted to store some information about songs, right? What would be helpful to have? The name of the song is helpful, maybe an author. So in this case, we also have tempo that just like, it's like a metric for each of the songs. And this is how we would store them, right? We have keys, which is like when you open a physical dictionary, what are you looking for? The word, right? So for example, you want to look up a definition of, and I'm suddenly blanking on all the definition, suddenly, right? Like what does suddenly mean? So you open the dictionary and then you look for that word, for that key suddenly, and then it will have some definition, which in Python way we call it values, right? So key value pairs. And what is really important to note that keys must be unique, because you wouldn't open a dictionary and then find, a page with a bunch of the same words. Now, every word has its own definition. So in the same way in Python's dictionaries, keys must be unique because that's how we access the values, right? So having this basic setup, let's try to visualize it. So for example, if I translated it into the tables that we love and cherish, this is how it might look like. So in the dictionary called song, on the left-hand side, I have my keys, and on the right-hand side, I have my values. Well, how do I access them? Using the keys, right? And the syntax here is slightly off. So instead of using maybe dot notation as we did with structs in C, here we're still using those square brackets and instead putting keys inside of the quotes. So by having a dictionary song and key name, I can combine those two things together and access name of the song. Perfect. Well, what if I wanted to add something? I can certainly add more stuff to my dictionaries. Again, remember that in Python, we don't have this sort of like static memory. It is very dynamic. So we can resize things, we can add more things, we can delete elements from lists or dictionaries. So here too, we can just add another key, in this case, album, and then specify the value that it would correspond to, and the dictionary automatically resizes to accommodate for this addition. Well, what if we needed to store more songs, right? I would guess that most of you listen to more than one song, right? So how do we keep track of that? Well, using lists, right? So again, it's how we had the notion of lists of structs or hash tables, right, where it was like the array of linked lists. Here too, we can combine things together. So in fact, this screen shows songs as a variable that is storing a list of dictionaries. So what's giving us the list? These square brackets, right? They're saying we have a list of some elements that are separated by commas. And then everything that's inside is dictionaries, like they're individual dictionaries that you can imagine stored on, on one line, or sort of like in its separate boxes. So a list of dictionaries. Well, how do we work with it? In a very similar way, right? We're again just like adding a little bit of more layers. So if I wanted to access the very first line of like the name perfect and then tempo 95.05. If I wanted to access that element, I can literally just use the square brackets, the index that the song is at, and that would return the entire dictionary, right? So all the information that we have for that song. Well, having an entire dictionary is not really helpful, right? Like I want to have just specific information. So for example, if I was grabbing the last song, so song's 3 and it's the 4th song, but the index is 3 because recall we start counting from 0. if songs 3 returns that entire line, the entire dictionary, how do I grab the specific name? Like, I really want to grab just him and I. So for that, I again use my key, right? So by looking at this dictionary, I can tell that him and I is a value that I can grab using key name. So going step by step in the order in which we set up this data structure, recall that songs is a list. So that's why we start by indexing into the list first, grabbing that entire dictionary, right, that is stored in index 3, and that after that, we're sort of like stepping into the specific key value pair and grabbing the value that is associated with key name, in this case, him and I. Okay? And we will get more practice with this in just a second, but very powerful combination of two data structures. Okay, and today we're actually going to play around with some songs. So back from 2018, the top 100 songs that were on the charts that year, we're going to create our own playlist, picking the specific tempo that we're looking for. But lastly, let's talk about another tool that we now have in Python, file IO, input output. And we in fact had it in C. Recall when we played around with recover, where we had to open the images, open some files, or write into them. We already had them, but again, it just was like a little bit more complicated. We had to account for the number of bytes, the memory where it's coming from, the addresses. In Python, it is much more simpler. And in fact, the next 3 slides, you can see that you can open a file with just 2 or 3 lines of code. So to start with, we're going to have the opening line, right? Like the line that will allow us to open this file. So with open, the specific file name that you would like to open. As file, again, file is a variable, you can use whatever you want. The next part is opening it specifically for CSVs, because that's what we're going to work with today. We're going to go into library CSV, and then from there, we're going to grab a specific function called dict reader. And the powerful point about dict reader is that it sort of like handles all of the conversions itself. So if we have a CSV file, right, that typically has some headers, some columns with information under them, what dict reader will do, it will associate the headers, right, like the keys, with the specific values that are stored under that column. So very similarly to what we just saw right here, this might as well be a CSV. And the way that dict reader works, it will parse all of this information in a very neat list of dictionaries that then we can access. Well, let's go back to this part. So file reader is again a variable. You can use whatever other variable you would like here, but the syntax for using the dict reader itself is csv.dictreader and then putting the file that you just opened on the line before. Well, what is the next part? After that, we're pretty much done, right? Like we can do whatever we want with our file. So in this case, what I would like to do is just go through every single row, right? I want to look at every single song, perhaps grab some values, which we're going to talk about in just a second. But because my CSV file got read as list of dictionaries, for row in file reader will be the row part, right, will be the dictionary. So every time my for loop iterates, like at every line, what I will see on my end, if I wanted to print out row, for example, or access it, would be a dictionary for that specific song. And then after that, there are all the different manipulations and operations you might want to do with it. Well, what are we going to do next? We're going to play around with some songs from the top 100 charts from 2018, and we're going to make our own playlist based on the tempo preferences that you have. So let me go back to CS50.dev and let me open the file that I pre-downloaded called playlist. Oops, I want to do code. playlist.py. Alrighty. Let me clear the terminal. Let me close all of these tabs so that we have a clear slate. Okay, here we go. So what we have here set up already is the gettingInt function, right, from the CS50 library to get users' input for min tempo and max tempo. And one thing we can do, right, if you don't want to have CS50.getInt, a handy trick is from CS50, we can import directly that function getInt and simplify this part by just calling the getInt function, okay? Next, we already had pre-set up an empty list called playlist where we're going to put our preferred songs, right? And then on the to-do is read songs from the CSV file into the playlist, filtering by the min and max tempo, right? We want to make sure that the songs that we're putting in the playlist are strictly between the min and the max tempo that we got from the user. And in the end, we want to print the song titles from that playlist. Well, let's take it step by step. So first thing that I'm going to do is I'm going to declare a file name. So the file is called 2018 top 100.csv, right? Just so that I don't have to type this out. Next, what I'm going to do is the line of code that we just saw on the slides, right? So with open, I want to open the file that has the file name I just defined above as file, right? Keeping things very simple. So with open allows me to actually just keep the file open only under it, right? So see how automatically it indented? It means that after I go back, I do something, right? I do some things here, and then I go back to the indentation of width, my file will automatically close and I don't have access to it anymore. So there's another way to do it using open and close, but if you want to just do some quick operation with your file and then close it immediately after that, with open is a really great tool to do that. Well, let's go back to the things that we actually want to do with the file. The first step would be actually reading it as a dict, right? So what we want to do is using the dict reader. And what are we reading? File, right? So sort of a little bit like backwards, but file is what we opened after we called open file name. We're going to pass it into dict reader to parse it into a dictionary or a list of dictionaries rather, and that will then be stored in file reader. Let's try to run it to make sure we're on track. So playlist py, minimum tempo 10, maximum tempo 40. Something's wrong. It's saying dict reader is not defined, but I'm pretty sure that's a function. Like I'm pretty sure I can use that. Well, recall that dict reader comes from the CSV module. So what we could do is either say csv.dictreader or do a similar trick as we did with the CS50 library and say from CSV import dictreader, and then we don't have to specify it again. Okay, so let's try to running it again to make sure everything is good. Okay, so no errors so far. Well, let's keep going and recall that I mentioned that dictreader will parse the CSV file into the list of dictionaries, right? So how do we access each dictionary by itself? Well, we can just use a for loop, right? So for example, I can say something for song in file reader, and let's just print out what the song is so that we can see a visual example. So let me run this line of code again. We're gonna set some tempo. And again, what I see is just dictionaries, right? They're separated by new lines because we're just printing out one dictionary at a time, but we can see that they all have the same structure of name and tempo being the keys, and then some values associated with it. Okay, so if every row in the file that we read is a dictionary, right, and I can access one by one, how do I access the specific tempo, right? Like that's what we're looking for. We need to figure out how to filter this CSV file by tempo. Well, we can use the key associated with it, right? So if song is a dictionary, then I can say song square brackets tempo, right? And that should ideally give me just the numbers. Let's set some tempo. Oops, I'm not printing it out. Okay, let's try this again. And then if I print out song tempo, and let me clear it and run it again, 50. Now I see just the numbers, right? Not all of the dictionaries that I had before. So helpful, right? We finally got to the part where we're like, okay, we have the tempo. Now we can filter by the min and the max that we set up above right here. And what is helpful for filtering it? If statements, right? So we can literally just set conditions saying that I only want songs that have tempo higher than the min tempo and less than the max tempo. So again, you will see a very cool trick about Python that we didn't have in C. So let's start from the beginning. So if song tempo is greater than min tempo, right? And song tempo is less than max tempo, then let me just print it out for now. Okay, let's style 50 this. I don't know why it's indenting that much. Okay, well, maybe that's how it's supposed to be. All right, so let's just print this out for now. If I run python playlist.py, oops, I forgot a quote. Okay, let's clear this, run this again, 10, 50. Not supported between instances of str and int. Str is a string, but what does it mean, right? Not supported between instances of string and int. Well, recall that when we're reading information from the dictionary, the reader doesn't really know what is a number, what is a string. It reads everything in altogether strings. So if we actually want to access the sort of like numerical value, what we need to do is convert it or sort of like cast it, right, to an appropriate data type. And in this case, I'm using float because notice that, let me open the file name. So notice that a lot of the tempo values are floats, right? There is some tiny differences that we want to make sure we catch. Okay, so let's cast these guys to floats. So now we could compare them. Okay, so let me clear the terminal one more time. Run this program, minimum tempo 10, maximum tempo 50. Still not seeing anything. Let's try going higher. Maybe 10 and 100. Okay, here you go. That was a little bit low for the tempo. But see how now I am getting only the values between 10 and 100 here on the bottom. So I would argue that the algorithm is doing what I wanted to do so far, right? It's reading in the file as the list of dictionaries. I am looking at only one dictionary at a time using my for loop, And then on line 15, I'm filtering strictly for the songs that have tempo higher than the minimal tempo that I set up and less than the maximum tempo. Well, we actually didn't want to just print the songs, right? We wanted to create a playlist. So recall that before I made just an empty list called playlist, and now I want to add values to it, right? What would be helpful here? The append method, right? So if I wanted to just add song after song to my playlist, I could simply use playlist append, and then inside of it, I'm going to put song name, right? Because these are my headers. These are the keys of my dictionary as well. So in the very similar way in which we accessed song tempo, right? We can access the name of that song and then add it to the playlist. Well, to make sure I'm actually adding the songs, what I'm going to do is for song in playlist, print song, just to make sure that I'm getting the values that I need. Okay, so let's set minimum tempo maybe 80 this time, and then the maximum as 150. And then we have some songs that were appended to the playlist list that we're now printing out right here on line 19 and 20. Let me clear the terminal and maybe collapse a little bit so we can take one final walkthrough through our code. So called in the very beginning, we imported some functions. After that, inside of main, what we're doing is grabbing some value from the user, specifically the minimum and the max tempo that I would like to see for the songs that they would like to see in their playlist. After that, declaring an empty playlist, right, as just like a list. So using these square brackets, that's the syntax for just creating an empty playlist that we can then populate. I'm just creating, like a string file name just to make my life easier down the line. And then after that, using line 12 and 13, opening that CSV file and reading it in as a list of dictionaries so that I could use it later to manipulate some data. After that, I am looking at one dictionary at a time, right? Since it's a list, using for song and file reader will give me just one dictionary. And then here using some, if statements that we were familiar with before, and then just a different keyword, and instead of the ampersand that we saw in C, I am able to filter out for the songs that have the tempo between those two values. And after that, just appending to the playlist the songs that I just found. So using the keys to access the values in my dictionary song, I can get the values for tempo and the name. And in the very end, I'm just using a very plain for loop to print out the titles of all of those songs. Okay, that was a lot. Lots of new syntax, CSVs, dictionaries, if statements, etc. Definitely encourage you to sit down and try to go through it on your own, or look at the simple solution right here and try to understand all of the small bits. But this will be it for now. So I'm gonna go back to the slides, and thank you so much for joining us for this week's section 6. We'll see you next time.